Good morning, everyone. This is Sireen Sakha going to be your host for this particular session. And I would request everyone to please take your seats and clear the aisle area. I would also request everyone to please put your mobile phones in the silent mode so that there is no disturbance during the presentation and, of course, with the session. It is absolutely my privilege and honor to welcome all you fine people, distinguished dignitaries, guests, eminent speakers, and our respected moderator to the second international conference, Green Hydrogen India, in Bharat Mandapam, Delhi. It is such a brilliant morning, and definitely with all fine people, it will be a brighter and a better nation. Shubham Karutti Kalyanam, Arogyam Dhana Sampada, Shatru Buddhi Vinashaya, Deepa Jyoti Namastute, Deepa Jyoti Namastute. Salutation to the light of the lamp, which brings prosperity and auspiciousness and destroys the inimical feelings from inside. And of course, with that note, we would like to say that we are definitely heading towards a renewable, sustainable, and a brighter future. Ladies and gentlemen, this morning we are going to be having a session on new and innovative startups in green hydrogen electrolyzer. And to continue with that, it is our privilege to have all our eminent speakers along with us today. We have Mr. Rochan Singh, the Chief Technical Officer, NewTrace. It is absolutely my honor to introduce him to you. Mr. Sinha, he is a J.N. Tata Fellow with 10 years of experience in the development of novel materials for renewable energy storage and generation technologies such as batteries and electrolyzer. Please join me welcoming Mr. Sinha, the dais. We have along with us Ms. Suruchi Rao, Chief Executive Officer, Ossus Biorenewables. It is a privilege to introduce Dr. Suruchi Rao. She is the CEO and co-founder of Ossus Biorenewables, a Bangalore-based green hydrogen supply company. The startup has developed an AI-powered intelligent bioreactor, the OB Hydrocell, which accesses organic content in the water waste from process industries and supplies these industries with on-demand and on-site hydrogen gas. Ladies and gentlemen, please join me welcoming Dr. Suruchi Rao. It is a privilege to introduce to you Dr. Sumit Chowdhury. He is an experienced CXO, a serial entrepreneur and global thought leader in the field of digital infrastructure and economy, telecom, and information analytics. The smart and sustainable cities, climate change, spanning all aspects of ESG. Ladies and gentlemen, please join me welcoming Dr. Sumit D. Chowdhury, founder and Chief Executive Officer, GreenEarthX. It is an honor to introduce to you Mr. Aniruddha Kadvekar, founder and director, N3E. He has over 12 years of experience across the energy, infrastructure, and technology domains. In the past companies, he has worked on cross-functional assignments across oil and gas, wind, solar, water, logistic, real estate sectors. Ladies and gentlemen, please join me welcoming Mr. Kadvekar, the dais. It is a pleasure to introduce to you Ms. Ritika Gaur, is the project manager, marketing head at Sohhytec, a cutting-edge company specializing in green hydrogen production, headquartered in Switzerland. Ladies and gentlemen, please join me welcoming Ms. Ritika Gaur. And it is a privilege to introduce our respected moderator who will be moderating the entire session. Mr. Pawan Mulukutla is the Executive Program Director, Integrated Transport, Clean Air and Hydrogen at World Resources Institute, India. He leads the team's development of synergistic and action-oriented research program to support India's ambitious decarbonization journey through effective, equitable, and inclusive mobility solution. Ladies and gentlemen, please put your hands together for Mr. Pawan. I would request a respected moderator to please start the session.
Thank you, and a very warm welcome to everyone. Good morning. I think we have a lot of excitement in the room that I can clearly see. It's completely packed, and a lot of people are also standing. So it also shows the interest to actually understand what is the kind of innovation that we're talking about in this mission. And, you know, since the launch of the National Green Hydrogen Mission earlier in 2023, and it's almost going to be close to 2 years now, I think we have been really looking at, you know, what is actually it's possible, what is the innovation in electrolyzers, what are the new technologies that are going to come, how do we really come up with, you know, green hydrogen. I know I have gone through many of your backgrounds in terms of what your companies are working on, and that seems to be very, very exciting, and we are at a very pivotal moment in India, and the startups specifically in the green hydrogen space is something very interesting. I've worked closely in the energy sector, in the EVs and in the other areas, but hydrogen always has been fascinating. And I kept wondering, what is it that we are going to see as innovation? And I'm glad that we are having this session. So the format of session that I also wanted to introduce to all our audiences, we'll have a 5-minute presentation by each one of you. So I would really request that if you could allow me to allow you all to stick to your time as a moderator, that would be really helpful for me. And after these presentations, we can then get into a Q&A session. And I would really request the audience to really support me in this Q&A. So please be ready with your questions. I do have a certain set of questions, but I do want to make this discussion as interactive as possible so that at the end of the day, there is something we all learn, and then there is opportunity to collaborate and take these conversations forward. So without further ado, let me call upon, in the order that I have, Rochan, why don't I call you to start with your presentation? Please give a big round of applause for Rochan. Thank you.
Hi, morning everyone. No, audio doesn't. Yeah, okay. Thank you. Good morning, everyone. My name is Rochan Sinha. I'm, as Mr. Pawan said, I'm the co-founder and CTO of NewTrace. NewTrace started off back in 2021 with the vision to fight climate change by decarbonizing the world, starting with heavy industry, because that is the part where people don't focus on usually. How we are trying to do this is by developing cutting-edge electrolyzer technologies, which I'll talk about briefly, to make green hydrogen production affordable and scalable. And how we are doing this is by building a new kind of electrolyzer technology called membraneless electrolyzers, with the lowest capex, most efficient electrocatalysts to give the best efficiencies and a dramatic simplification and localization of the supply chain. This was started by me and my co-founder Prashant. Both of us spent around a decade in Europe, and after coming back, we decided to stay back because we could see the effects in our hometowns of climate change. And we built up our team in Bangalore, here in India. We built up a 50-member team with people, with multiple people from PhDs to people from different large-scale industries like Siemens, L&T, GE, etc. And we have been lucky enough to be have been invested in by the peak marquee investors in India, including Peak 15, Speciale Invest, and Axelor Ventures. So we already know a lot about hydrogen. The main thing that you need to understand is to have a breakthrough in green hydrogen production. We need to get the cost down, both in terms of the capital cost as well as in terms of the operational costs, which mostly is electricity. So you see here that if we can get down the capex to $1,000 per kilowatt and an efficiency of around 45 units of electricity used per kg of hydrogen, you can get around the range of $2.50 per kg of hydrogen, which is similar to that of gray hydrogen. And this is where the market gap lies today. The technologies that exist are either have extremely good efficiencies but are very expensive to manufacture, or they are cheap to manufacture but do not have such high efficiencies. We are trying to break this cost efficiency paradigm. The way we are doing this is with membraneless electrolyzers. So in a general normal electrolyzer, you have basically an anode where you have the oxygen production, you have a cathode where you have the hydrogen production, and you have a plastic material called a membrane, which separates the two gases. These membranes are extremely critical from both a supply chain perspective. There are only two major manufacturers of these membranes, both based out of Europe, which is an extreme supply chain risk, both in terms of price and availability. Also, they are extremely critical in terms of how sensitive they are to water conditions, to electricity conditions, etc. To break this, we basically decided to stop using membranes and instead use the flow of water itself to keep the gases separated. We built the first membraneless flow-by technology back in 2021. And within 2 years, we built up to a 100 kilowatt system, which is now commercially deployed. After that, we have also built up a porous electrode technology, which is allowing us to scale up even larger to a 1 megawatt system. And this is something that we are in the process of currently. What are the benefits that membraneless electrolyzers have? One is that we have achieved efficiencies of less than 48 kilowatt hour per kg. We have a capex of around $1,000 per kilowatt, so equal to alkaline. And we do not use any rare earth metals. So we don't use any platinum or iridium, but we are matching or even beating the efficiencies of other high efficiency technologies like PEM. We do not have dependence on membrane suppliers. As I mentioned earlier, it's a monopoly or a duopoly, and we have broken that dependence. We are compatible with renewable energy sources. So we have the cost of alkaline, but we also are able to work with solar and wind. And finally, we are able to get a lifetime of around 80,000 hours, which is critical because these plants, you're not putting it up for a year, you're putting it up for 15, 20 years, and you need the system to be able to run for that amount of time. So with the current technology that we have, we are able to get a LCOH of around $2.50 to $3 per kg, depending on the electricity cost and other factors. But this is extremely close to the cost of fossil fuel-based hydrogen of around $2 per kg. Like I mentioned earlier, we have had a very fast breakneck speed of development. We started off with a simple proof of concept in a lab in IIT Madras back in 2021, December. We quickly built up a 1000x larger system, the first 1 kilowatt system in the world of a membraneless electrolyzer in October of 22. And then we built up even faster with the 100 kilowatt system. And now we also have a fully functioning plant up and running in BPCL since last year, December. Right now, we are working on a megawatt scale system, and we hope to have it up and running by the end of this financial year. Thank you.
Thank you, Rochan. I have a lot of questions for you, but I'll come back in our panel discussion. Yeah, you did do it. Thank you so much. Let me now call upon Ms. Ritika Gaur, Project Marketing Head at Sohhytec, to really talk about the innovation that your team is leading. Sorry, Sohhytec.
A very good morning, everyone. My name is Ritika Gaur, and I'm presenting on behalf of Sohhytec today. Moving forward with the presentation, We come up with the 10 years of research and development and 100 plus years of combined experience
Ritika,
of the...
1 second. Can we get the presentation up on the screen?
Because I can see your presentation.
Yeah, thank you.
No problem. With the 10 plus years of research and development and 100 plus years of combined experience, we have come up in the market with the product name as R. We hold world best in terms of green hydrogen producers. We just not develop, we develop, build and operate garden of herbs, forest of herbs. Here I wanted to show through this video how this whole integration take place. What is exactly ours? What is this technology? We completely believe that the world is on the transit mode from conventional fossil fuel to the new renewable source of energy, that is hydrogen. Being hydrogen one of the cleanest fuel and the fuel of the future. As per the research report 2023, we understand that 96% of the hydrogen has been produced from conventional fossil fuel that has been centralized, and being it's in terms of costing, it is not economical, it is high in pricing. So what Sohhytec has brought up in the market? Sohhytec has come up in the market with the product name as R. Basically, R is a Latin word which means a living tree. One single R is equivalent to 100 plus living tree. How does this whole technology work? With two renewable resources, sunlight and water, we are producing heat, electricity, hydrogen and oxygen at the same time. How does it work? Let's just dig into it. So basically the sun rays falls on the concentrator and get concentrated inside the reactor. Inside the reactor, there is a photovoltaic panel which converts this high concentrated sunlight into electricity. And through electricity, we are splitting the water into two parts, that are hydrogen, oxygen, and heat and electricity at the same time. That's the reason we are calling it as a cogeneration system. This whole technology is known as integrated photoelectrochemical technology. Moving further, how we see our technology is a bit different in the market. One single hour saves up to 80 tons of carbon dioxide per year. We hold world record, as I mentioned, high in twice more efficient, twice less in terms of economically, in terms of pricing, and it works 24 hours, morning on grid and evening, morning on sunlight and evening on grid. Let's just try to understand this technology in a bit more refined manner from Saurabh Tembune, who is the co-founder and the CEO of Sohhytec and an alumni of IIT Mumbai.
So now, let's dive slightly deeper into what makes this innovation of the technology interesting. In its whole essence, the R looks something like this. So on the right side, you see the real picture of a product scale pilot. So what you see, in fact, is a big reflector. There's nothing special. The light falls on it, it concentrates light by a factor of 1,000. but this has been existing since ages. So what's innovative here is the small device, which in fact is just this small, which sits in the center focal spot of that particular collector. And that's what is performing artificial photosynthesis. If I go in more technical terms, this is the more detailed schematic, but I won't bore you with what exactly happens here. But essentially what we are doing here is we are combining multiple physics as well as chemistry in one single device, which allows us to be very efficient as well as cost effective. And in simple terms, this is how it works. So basically the concentrated light falls on that artificial photosynthesis device. We simply put water into the device, and using the sunlight, the water is broken into hydrogen and oxygen already separated. And the basic principle behind this is basically photoelectrochemistry.
So as I earlier mentioned in my PPT, that it works 24 hours, morning on sun, evening on grid with 100% capacity. How we are scaling up in the market? We are scaling up in the market. We are coming up in the form of arbs of garden and forest of gardens. So we are basically calling it 100 plus arbs as a garden and 1000 plus arbs as a forest. Talking about the durability of the product, it's 25 years in widely geographical area with 2 times more efficiency, 2 times less in terms of pricing. And of course, the land which has been utilized for the arbs can be utilized for multiple other usage like parking and agriculture. Talking about the product readiness level, as you can see, the product has already reached the green immersion zone, which is as mature and ready as per photovoltaic and PM electrolysis. We have come up in the market with the 3 different sizes, 9 meters, 13 meters, and 25 meters. 9 meters produce up to 10 kg of hydrogen per day, 13 meters up to 20 kg of hydrogen per day, and 25 meter up to 80 kg of hydrogen per day. Moving on, how we are developing. As I mentioned, we just not develop, build, and operate. We are taking the garden of arbs as a turnkey project, and of course, the forest we are servicing as a client, as a power and fuel to the client. Talking about the product positioning, the product has already reached the sustainability level in a very high, and talking about the pricing, it is very low in terms of economic. Here is again one of the videos which shows that pilot project about to complete in Switzerland itself by next month for a steel industry. It doesn't have an audio, so. So thank you for that. And this particular graph, we wanted to show how we are scaling the solar plant. Likewise, we can scale the art plant. And of course, we are going from megawatt to gigawatt. 24 hours, 100% capacity from sun plus grid. Of course, the 90% usage of the land. As I mentioned, that the land can be used for other multiple usage. 99%, the product which has been used to develop art is recyclable. Talking about the market segment, as I mentioned, this thing, particular hydrogen can be used as a fuel, as a raw material for agriculture, steel, and other fertilizers industry. Yes, one of the most important pipelines of ours in this slide, that by 2025, we are expecting the projects will be initiating in India and Europe. In Europe, it's starting in like France, Spain, and Germany. By 2026, we are expecting to finish. By 2026, the project will be initiating in Chile, North America. Yes, we have got the world recognition from the President of Switzerland and President of Chile, North America. And we are looking for much more forward for such recognitions. And in the end, it's a Swiss technology, Swiss manufacturing. Meet the dynamic team, the main mindset besides this technology based out in Switzerland itself. We are headquartered in Switzerland with a branch office in India, Delhi. Thank you.
Thank you so much, Ritika, for introducing the whole arc. I think it was quite an interesting concept and thinking, and glad to hear that the pilot is actually happening and will be completed next month. So looking forward to the learnings and results from that. Moving on, I would like to invite Mr. Aniruddha, founder and director of N3E, to please start with your presentation. Thank you.
Hello. Hi, everybody. Based on the moderator's request, I'll probably be skipping through a few slides. So, but just to set the context, basically what we are trying to do here at N3 is that, as we all know that green hydrogen ecosystem, while of course, hydrogen is decades old, green hydrogen ecosystem is still developing, it's still evolving, whether it is in terms of technology, whether it is in terms of regulations, whether it is in terms of design standards, and a lot of these dimensions, work together in order to define how successful any particular actual project or a plant, is established and delivered. At N3, what we are basically trying to do is that, we are developing ourselves as a complete integrated solution provider, right? Where we have the 100% product portfolio, which is required to make a particular green hydrogen facility successful. And then, of course, manage it throughout the life cycle as well. N3 is incubated within Sopan Group, which holds a 2-decade legacy into the gas technology and engineering domain. I'll skip this. I'll just go straight to this slide. Yeah. Okay. So, at N3, we look at the market in terms of two broad, categories. One is the centralized hydrogen ecosystem, which we are talking about the large scale hydrogen generation or even ammonia generation that is being done for refineries, steel, fertilizers, or even the export hubs that are being built. Second, there's another major category that is evolving and developing is the decentralized hydrogen infrastructure, right? So here, basically what we are looking at is we are looking at certain pockets of opportunities, pockets of use cases for green hydrogen through primarily two segments, green hydrogen blending with natural gas. And second is the hydrogen mobility space, where we have the complete end-to-end integrated solution. We have been developing our product portfolio now for the last 4 years. We started back in 2020, and we have our own product portfolio available for hydrogen blending, hydrogen dispensing, and the electrolyzer. The blending and dispenser is our own proprietary product and design product. And for electrolyzers, we are basically working closely with a couple of technology partners, and we are building the product in India. This basically, along with Sopan's capability on compressors, we basically complete the entire loop and make sure that we are able to provide end-to-end solutions. I'll quickly, demonstrate some of the projects that we have already delivered and we are already working on, right? And then probably, add a few thoughts on that. Of course, I think a lot of you would probably be knowing about, NTPC's project in Kavas, which was, India's first green hydrogen production and blending. So this entire system was designed by us and the products were built by us. Now, of course, this has been running for quite some time. And I think in this forum as well, I think on day one, a report was published by NTPC on this particular project. We are right now setting up a couple of more projects we are doing for Adani Gas, which is again currently under commissioning, right? So this again is a similar hydrogen generation and blending system that we are setting up. We are doing one more project for an R&D institute in Gujarat, which is again likely to get commissioned by end of this month. This is for an R&D application. We are working with one of the manufacturing companies. This is a very interesting use case because basically, the manufacturer, they are currently using natural gas in their furnaces, in their plant. And basically, motivated by, their ESG metrics, right? They are looking to reduce the carbon footprint of their products, right? As a result, they want to set up this complete in situ facility for hydrogen generation, of course, clubbed with renewable power, generation, compression, storage, and then blending for their furnace application. So this is a project that is currently under execution. This is a roughly 300 kilowatt system that we are setting up end to end. Plus, we have just started one engagement with a large energy major in Southeast Asia, where they are basically looking again at hydrogen blending as a key lever to decarbonize their entire grid, right? So what we are doing with them is basically we are doing a detailed feasibility study with them for the various applications within their grid, right? Then second phase would be identifying certain pilot project implementations, followed by long-term scale up in order to make that as a key lever for their decarbonization strategy. Moving on from hydrogen blending, we are also setting up a couple of projects in hydrogen for hydrogen mobility as well. Again, like I said, it's an end-to-end solution where we have our own product portfolio there. We are setting up the hydrogen refueling station for BPCL, which is being set up for the Kochi International Airport. This is currently under execution. We are also a consortium member in the Pune Hydrogen Valley, where we are the partners for hydrogen mobility. Here again, basically our philosophy in this is slightly different, where we are setting up a mobile concept, right, for hydrogen refueling. Especially when we know that today, while in the mobility segment, hydrogen is still, taking some time to scale up, right? So the biggest challenge, hydrogen infrastructure, refueling infrastructure is a very, very capex intensive, part of that whole value chain, right? So we are trying to create a mobile and a compact refueling system, right, which can be catering to multiple, requirements, right? Multiple pilots, multiple in situ or captive hydrogen, mobility fleets, right? In order to optimize the whole, overall ecosystem. Because otherwise, right now, what happens is a lot of times the initial upfront capex itself for a pilot project for hydrogen refueling becomes the deterrent, in order for the decision to be made. Right, so that's something that we are going to be setting up in this hydrogen.
Aniruddha, if you can wrap up.
I've wrapped. I think. Thanks. I think there's a shameless plug-in here for the fact that we are hiring, but thank you for your time. Right.
Thank you so much. Quite interesting to see some of the live projects. Now I will call upon Dr. Sumit Chowdhury, founder and CEO of GreenEarthX, to share his presentation with all of us. Thank you.
Good morning. Just to give a quick introduction, my name is Sumit Chowdhury. I am the founder and CEO for GreenEarthX. Many of you just attended. How many of you attended the H2 Global presentation just before? Most of you probably. So we are sort of set up similarly to create the world's first trading platform for clean green fuels, which are all non-fungible products. So essentially, we want to facilitate the demand and supply to come together on one platform. Essentially, and there's the biggest problem that we are seeing. What problem is that, as you know, hydrogen is moving to a decarbonization use case, high growth rate. I don't need to talk about it in this conference. It is fairly well known. But the biggest problem that everybody is seeing is that out of the 2,000 projects that are in IEA's register, 75% of them are not financed and 98% of them do not have an offtake agreement. That means the remaining are all captive plants. And we all hear that captive plants are getting done. Adani and Ambani, I mean, Reliance will do it because they have their balance sheet. But project finance is not happening in the hydrogen sector. And project finance is not happening because offtake is not there. And offtake is not there because there is no trade finance in the industry. So we are trying to solve this problem. The suppliers don't know who the producers are. The producers don't know who the suppliers are. There are many, many small, there are probably a few hundred people who have committed to make hydrogen in this country, but you will not even know their names. How do they sell their product? In fact, we came across this opportunity because we were trying to set up a couple of hydrogen plants in my other entity, and we realized that there was no marketplace for selling it. It is a globally distributed market. There isn't enough supply or demand in one market to be justified. So we have to create a global platform. And finally, certification. Every country has a different certification, different rules and regulations, different trading policies, different commodity and financial regulators that we need to manage. So we are essentially, if you take a look at the World Hydrogen Council and McKinsey's report, out of the 4 recommendations that they do, all 3 of them have got to do with setting up trade. So facilitating trade is going to enable the hydrogen ecosystem to speed up. So what are we solving? How are we doing it? We are creating this trading platform, which will be a certified platform. So we have tokenized green fuels. So green hydrogen, ammonia, SAF, methanol, ENG, and biofuels. we have got the patent for tokenization of these assets, and we are going to trade these tokens on our platform. And we are going to start with green ammonia, SAF, and methanol, because all of these products are already trading today in the world market. There is enough demand. Then we are going to move to green hydrogen, and finally moving into green energy, as well as in carbon credits and IRA credits globally. And there will be transaction users who are going to be the buyers and sellers. There are also going to be contract enablers like banks and lawyers and insurance companies and storage companies who are not part of the actual contract, but they enable the contract. And finally, you've got the regulators, the world schools, regulators, governments, research institutes. They will also need this data to understand the demand and supply of green products. So I mentioned to you that we have already got the patent for tokenization. So we are setting up an orchestrator, which is essentially like an exchange, a commodities exchange. We have also got the marketplace of people who are going to facilitate the trade that is going to happen on the exchange. We are setting up a global H2 index. So all these fuels will be tied to an index. So our contracts will be index linked contracts. A lot of offtake agreements are not happening because people cannot predict the future price of a particular commodity. So unless there is an index or there are multiple indices, we'll not be able to do it. So we are setting that up, and we are also setting up a hydrogen registry, very similar to the gold deposit registry. This will be the hydrogen registry. I'll not go too much into it. We are going to be set up in 8 countries, in the US, Europe, India, in Brazil, Hong Kong, Japan, and Australia. And they will all be connected using beacon. Like many of you know that we are setting up, not we as in India, is setting up ONDC. This is like a global ONDC for hydrogen trade. It is supported by the Beacon Foundation, which has led to the creation of Aadhaar, UPI and all. So they are setting this up as a digital public infrastructure. It will operate as a network of exchanges working together to solve this problem of demand and supply matching. So a member in any of the geographies will be able to trade with a member in a different geography, both following their own rules. And we are also looking at translating the standards. So standards in Japan are very different than the standards in India, and most of these are evolving. So we have come up with a translatable standard product, which is going to essentially allow you to translate these standards across. And the certificate that will be there will be traded independently of the molecule. So there was a question asked by Sir in the previous session about you importing 200 tons of ammonia, and then you're exporting 200 tons of green ammonia. You don't need to do it. You just need to export the certificate that the 200 tons of green ammonia that you produce over here can be used over here at the same price as what your import bill would have been. So you actually save on import. You can trade your green certificate in Europe because they need the green certificate. They can take their green or gray ammonia from there, the green certificate from here. So we are essentially setting up a global network of like a grid, a global grid, a soft grid of hydrogen fuels across the world, so that people don't have to actually ship the fuel. They can ship the certificate only. This will solve many problems across the world. So we are, the people who are working on this, half a minute more, are coming from people who have worked. I was the president of Reliance Jio, the CIO for them. And I also have worked across IBM. I've got people who are, my co-founders are from Google, Microsoft. We have worked in global companies. We have also got 6 bankers in Europe who are working with us. We are also setting up equivalent of Hindco, as they mentioned, a fund that will actually create the offtake demand on our platform. There are 2 companies which have agreed to be the equivalent of a Hindco to actually trade through this platform. So thank you.
Thank you, Sumit. Quite heartening to listen and also understand that it's based actually on the backend protocols. I think that's one of India's biggest contribution, the digital public infrastructure. And I'm also excited to learn about this trading platform, and I'll have actually a lot of questions about it with you in the panel itself. Our last presentation on this panel, I'll invite Suruchi, actually. I left my glasses here. Suruchi, sorry about that. CEO of the Ossus Bio Renewables. Actually, we have spoken before, and it was I know that you have been doing a pilot in Jamshedpur with Tata folks, right? If I remember. Yeah, it's very interesting. So it will be good to actually hear the progress and, how far have you guys been doing this and where it's taking forward. So looking forward to
Fantastic.
hearing from.
I am going to cut the whole thing short a little bit though, because I understand the last weekend and I'm sure everybody has a lot of questions for my co-panelists and also for myself. So I'm going to take a shortcut here and speak very briefly about what we do as a company. We produce green hydrogen, the reason why we are on this panel. The feedstock for our green hydrogen happens to be the organic content of industrial wastewater. So to put it a little too simply, you'd say you're using wastewater to produce green hydrogen. We don't technically do that. We do something known as microbial electrolysis, but we won't go into that yet. Why? Because as Pawan very kindly sort of led our conversation here into this forum, I'm here to talk about the scale that we've managed to reach. Most people, when they speak about any technology which is an alternative to electrolyzer, always have two questions. Can it scale? Has it been done before? Considering the fact that we've waited 100 plus years for electrolyzers to materialize, I would say the question does ring a little unfair. But kudos to my team and to the work that we've done. I think we've achieved significant scale in a time span as short as 1 year, thanks to the VC funding that we raised 2.5 million last year. So I'm here to talk very specifically about that. These are a few of our sites, not one, not two, just short selection of it, because it really lends well to where we think green hydrogen and alternative technologies, alternative to electrolyzers, are headed to. We think we're the present of green hydrogen. Electrolyzers are the future. 2030 is too long to wait. And we're sort of here to prove that you can use other technologies and alternative feedstocks to get to where you need to get to. But it requires something extremely crucial. It requires a customer who is willing to A, de-risk your technology and has closed consumption capacity. So everything that Sergio spoke about, having to create a market, having to create a system, if you don't find a way to short circuit that as a startup, which basically means if you don't find customers soon, you will become another technology that grinds through TRL level, through TRL level. And we've been fortunate enough to work with customers like Tata Steel, like ONGC, the big picture that you see on my left. That is a plant that we have near Pune on top right with Eternus Fine Chemicals. Bottom right would happen to be Sayaji Maize products. So what is different about these three customers? The ones on the right use hydrogen for hydrogenation. Now, this is not something that we speak about. We speak about the chemical industry as someone who needs hydrogen. And if they had green hydrogen, they would make green chemicals. To be honest, this is the sector that is growing the fastest, which means that unlike ammonia and unlike fertilizers and unlike refineries, these guys are catering currently at 25%. Sorbitol, by the way, is India is the third largest supplier of sorbitol post-COVID because Europe couldn't recover and India took over the load of sorbitol manufacturing, production, and exporting. And Sayaji Maize products that you see there currently consumes about 2 tons per day of the green hydrogen that we make. They have the capacity to generate 300 tons of green hydrogen. Where is the 300 tons coming from? They have nearly 120,000 milligrams per liter. That's 120 grams per liter of organic content. Now, this is something that we will all start to talk about in a year or two because we need to treat water to be able to electrolyze or split it. So COD, the number that we talk about as a feedstock for hydrogen, will soon be something everybody talks about because it is going to add into the cost of being able to generate hydrogen. You will talk about recycling wastewater, sewage, or industrial to be able to supply the kind of water that is needed for splitting. We've sort of beat the curve. 2 minutes I'm going to spend on talking about the ONGC project. Now, you would always wonder, why does an upstream oil and gas company have to be interested in green hydrogen? Energy is energy, right? And when the energy transition is happening, everybody wants to be ahead of the curve. For us, the new energy team at ONGC was extremely crucial in understanding what it means to have scale. I have skipped a slide. A single company has the potential to produce 37,000 tons per year of green hydrogen because they have 55,000 cubic meters of wastewater they generate every single day. So when we talk about scale, this is what we talk about. And similarly, each one of our customers spread across admittedly a very specific area of Gujarat, Ahmedabad, and Maharashtra have the potential, we think, to generate more than 1 million tons per year of green hydrogen. In fact, why do we think this is something we can achieve is because of the technology, right? Our energy consumption is extremely low. And this is where maybe a double click onto what we do, what is the role of microorganisms, why is it called biorenewables would be critical. But this is the reason why we may be successful, why electrolyzers will still continue to try. Even at best, if you need 40 kilowatt hour for every kilogram of hydrogen, you will require massive renewable energy capacity that is difficult to achieve. I'm not saying impossible, it's just a question of time. It's when and not if. But it is going to affect the availability of hydrogen, and we can't afford to wait. This is where Ossus has taken a big giant leap in the last year, and we think we'll continue to grow. In fact, we think by the end of March March next year, 26, we will have very easily hit 0.7 MMTPY. That's 300,000 tons per year. It's as little as 750 tons per day. Very easy to achieve. You just need 50 TPD sites, 50 TPD each day at a refinery is very simple. Or you need 20 TPD sites. Take all your steel industry sites. That's the average production that you would get. This is not something impossible. This is also simply a question of having sufficient funding, having sufficient people to de-risk the technology, and of course, the last thing that we haven't really spoken about, transportation. Because when you produce volumes so large, you will start to push the hydrogen out beyond closed captive consumption. So we have about 6 months lined up. We're going to take expressions of interest for everything that is required. We're setting up a center of excellence for manufacturing, because you do need to be, we genuinely believe in Make in India. When we see that our partners who are manufacturing the sensors and the measurement units that typically get manufactured out of Taiwan move to Pune, the wave is in the positive direction. So we also want to keep our manufacturing, which is why localized, which is why we are basing our entire unit out of Ahmedabad. And the funding for all of this does come through from 3 sectors. It comes in from your customers who are more than willing to take up the CapEx. It comes from VC funding. It comes from private money. Most importantly, it also does come from selling hydrogen. Sometimes we forget that we are in the business of selling at the end of the day. You have to think like an energy company, not worry about the price, and start to talk about how much can you sell, what are my profits, what is the margin that I'm making. If you don't do that, you will constantly be reliant on someone else telling what is the direction a technology must take, instead of focusing on the technology itself. So thank you so much. I hope I stuck to 5. We have exceeded, but thank you guys.
Thank you so much, Suruchi. Very interesting. Actually, I'll start off with you with the questions itself, because it's very fresh in my mind right now. Let me have, you want to, yeah, please. Sure. But let me just start with my questions, and you can respond. What are the regulatory challenges that you see in terms of certification? Because that was the question that was passing through my mind while I was hearing you, in terms of acceptance of this as green hydrogen. I think that's one of my first questions to you. And I'll come back on the second one. Why don't we get started?
Sure. This time last year, we were very hopeful that BEE would allow us to classify industrial wastewater as biomass. MNRE did do that. I mean, technically, we are grade 2 of green hydrogen. But when it comes down to certification, TUV said as long as it's powered by solar, it's green. Doesn't matter. According to us, our balance sheet must start with negative. You have to think about it in the wastewater treatment concept, right? When you're talking about scope 3 emissions, you're talking about whatever is produced as water is treated. The organic matter also produces CO2. We are preventing a significant portion of that, because our process produces less than 2 kg per kg of the COD, or the organic matter in wastewater. Yet the balance sheet doesn't start with a negative for us. So we're a little disappointed by the way certification is done, but you've got to get up and move on. And so what we've done is our customers typically have solar assets that are powering a part of their wastewater treatment process. So we just need to make sure our battery limit aligns well. For some of our other customers, for example, Tata Steel, you're talking about a plant that was set up in 1908. It's fully built up. there's no additional space. So for them, we're announcing something very exciting. We have a lot of real estate available. The skid has roofing, the containers have extra surface area. We just need about 200 units for us to get started, the first pilot scale project. That's like powering a home. So we are looking to partner with people who can provide whatever is the necessary solar support for us to get going using the real estate that we have in and around our own plant. This is the next step that we're hoping to take, but we understand it's a bridge to jump, and there's a lot that people want to do, don't want to do. But in terms of certification, we are disappointed, but we'll go along with it. Yeah.
And quick follow-up question is, you talked about, this is based upon bioorganisms, right? And it would vary with the kind of the
Yes.
water treat. So a little bit curious about, how are you managing this, and what kind of technology is this? Because it will
Sure.
change from city to city, I'm assuming. And what has been your experience? Because you talked about 3 different sites and
Yes.
pilots that you're running.
Right. So a good way to frame that is, we're actually going to turn 7 this year. We're 7 years old. We're older. Yes, we're older than most people here on this dais. So what happened in the last year that didn't happen in the 5 before that, right? Basically the microorganisms. So now I'll speak a little bit, if you don't mind, about the technology that we have developed. People often think that we make biohydrogen. Unfortunately, that is not true. We make bioelectrons. So we break down the organic content to electricity or current. The rate of that current generation is dependent on how you select the microorganisms, because they're not artificially engineered, they're not genetically engineered, they're selected from the source of the wastewater itself. Now you have this community of microorganisms that has a certain, and now we have the same language that we use as Rochan, right? You have an ampermeter square because you're talking about a surface area. So you need a high current density from these microorganisms. And whatever happens at the cathode is essentially a PEM cell. Electrons, protons combine to make hydrogen gas. But the source of the protons also happens to be organic in nature, because you're looking at something known as short chain fatty acids. And I could speak 5 hours about that. But what we changed was, previously we would need anywhere between 6 to 12 weeks just to select for these microorganisms. So we would trouble our customers to send their wastewater all the way from Jamshedpur, Pune, Mehsana to Bangalore to our labs. We'd select the microorganisms, deploy them at scale, coat them onto the electrodes, and then ship them off to site. What has happened in the last year is that we've developed a new system where it has reduced from 6 to 12 weeks to 3 to 6 weeks. And very recently, we've done it directly at site, which means now there's no uptime, now there's no waiting. You're immediately able to get to a pilot capacity of at least 25 cubic meter per day of effluent, or depending on what is the organic content, anywhere between 50 to 1 ton per day, using just 2 reactors of 3 by 4 meter area. Maybe my CTO should give more details about this, but 3 by 4 square meter for a ton of hydrogen is impressive. But what's that difference, 50 kg to 1 ton? That's related to the type of organic content that's present there. But otherwise, the way of selecting the microorganisms, that's what we've managed to achieve in the last year.
Thank you so much, Suruchi. It sounds definitely a very promising technology. I have many more questions, but I do want to let the audience also ask, but I do want to bring in now Rochan on this. In the recent SECI tender, your company was awarded about 30 megawatt of indigenously developing stack technology for smaller units.
Yes.
So what are the opportunities and challenges on localization of manufacturing of electrolyzers and related components?
Yeah, sure. So the opportunities are that the electrolyzer landscape in India is still in a nascent stage. People are still looking at what technologies to. If you just walked around the conference, you would have seen that I think there was 2 stands, including ours, which had an actual stack in the stand. So the opportunity is to be a front runner in developing technology which is indigenous in nature. The challenges are also, so it's a double-edged sword, because when you're developed, like I think what Suruchi mentioned about de-risking, you need to find customers, you need to find the first players who would like to get into it and de-risk your technology, especially when it's a completely new technology that you're developing. So that is one thing, but we have been lucky enough to find customers who are willing to, take us up on that and really let us prove that we are able to do this. The other challenge is obviously developing, because it's a nascent industry, you are developing the supply chain and talent ecosystem along with you. We have been doing that since the beginning. We have basically worked with partners in order to develop different parts of the supply chain. And we have been able to localize almost 90% of the supply chain already, especially because of the technology that we chose to work on. The other thing is the talent. Hiring has always been a challenge. I think that's why he also mentioned it on his thing that we are always looking to hire. We're always looking to find talent. This is a new technology. You need people who are extremely smart, who don't need to know exactly the technology we're working on, but who can quickly and easily shift what they have learned over decades of experience into this new technology that we are developing. And we have been lucky enough to find these people as well, and we're lucky to develop these talents slowly over time. So now we have people who have been the first people in India to have worked on developing the entire balance of plant from scratch, from making the stack, electrolyzer stack from scratch. This is found in very few places. In academia, you find small scale systems that have been running for a while, right? But you don't find industrial scale systems of this kind before, especially when we started back in 2021. Now people are starting to also work on this, and I think that has been the good thing about doing this. The ecosystem has been developing rapidly along with us, and that has been an amazing opportunity for us as well. And the PLI scheme gives us the opportunity to scale it further. When you get the government support in building up a larger scale factory, you start actually automating some of the things that we are doing, right? And that will bring down the cost even further, which is what we want to do. And this will allow us to also spread beyond India and really become exporters of technology. We have usually been importers of technology and then scaling it up. We want to change that. I think that everybody here is trying to do that, is we want to become exporters of technology instead, right? Like not really take a technology. We want to give the technology to the people and globally. Right?
Yeah. No, I'm glad to hear your vision, which aligns with the Honorable Prime Minister's vision of, the Atmanirbhar Bharat also, right? And our 2047 goal. I have a quick follow-up question on that. I saw in your slide, you were talking about the, your electrolyzer being 1 megawatt, right? I saw.
That's the target. That's the target for this.
So where are you right now?
So we are at 100 kilowatt level. So the thing is that it doesn't scale linearly. So you build a certain size of a system, and that gives you the clear pathway towards a megawatt scale. One of the challenges we're facing is, where do we test a 1 megawatt scale system? Because there are not a lot of people who can test. That's around 400,000 liters of hydrogen per hour. You need to use it. And so we're working with customers in order to build up these systems and test these systems.
So when do you think you'll be at that scale?
So we'll be at that scale by the end of the financial year, so March of next year.
Interesting. That's great. And again, a quick follow-up on what you said. So how do you see that, we have set up in the National Green Hydrogen Mission, right? We have a target of the whole 5 MMTPA by 2030. Do you think that's achievable?
Yes, I do think so. I think what Suruchi mentioned about people are generally, we look at oil and gas, we look at ammonia, but then you have all these other players in all these other sectors, including steel, including sustainable aviation fuel, including food, semiconductor, who are already struggling with the cost of hydrogen, right? Like the gray hydrogen that we see at $2.50 per kg, $2 per kg, is not available to everybody. So there's already a scope of a large development of electrolyzers to cater to these up and coming sectors, because SAF and steel, although they're not using hydrogen right now, they're a huge market which is up and coming. And I think these are going to be the first adopters, because they're spending a lot of money on, coke, charcoal, diesel, whatever else they are using. So these guys want to shift to something more sustainable, want to shift to something cheaper. And I think so the 5 million metric tons might not be completely with the existing technology, existing use cases, but the newer use cases that are coming up will definitely fill in, and we will reach that 5 million metric tons.
Thank you, Rochan. Great to hear on that. Sumit, let me bring you in here right now. Spoke about the platform that you're developing, and you're connecting the buyers and sellers. I'm just oversimplifying it, but two questions. One is, Given that countries have varying priorities for carbon intensity and classification of low carbon hydrogen, how does your solution cater to the potential variation in the certification, which again ties back to what I was asking Suruchi earlier, of green hydrogen, including derivatives?
So the very fact that you use the word carbon intensity is actually the solution to the problem. It's like what we have done is we have taken, everybody defines green as something else. What is green? The percentages of various things that is different. We have come up with a way to come up with a hex value, like in colors. You have a hex value and then you have the colors. If I tell you what is light green, you will not know what is light green. But if I tell you the hex value is 4VD85, then you know exactly what it is. So, and it becomes translatable. As soon as you bring it to a number of all the parameters. So we are following IEA's hydrogen passport guidelines as sort of a common standard with a hex value, which can then go into a Japanese standard or a German standard or anybody else's standard. So it's a translatable carbon intensity thing. So suppose I buy 100 tons of green hydrogen in Japan. I'm going to get 100 tons of 100 tokens of hydrogen and 100 certificate tokens. The 100 tons of hydrogen can be sold at gray market prices, but the token, which is the certificate, will have the value, the premium. What will happen in one country, you will get a different premium. In the other country, you're going to get a lesser premium. In one country, you will get 98 tokens. In one country, you will get 96 tokens. In the third country, you will get 84 tokens because they define what is green differently. So we are basically creating a translatable standard of tokens between the countries. Hydrogen is hydrogen. You can produce it from the grid or you can produce it from renewable energy. Nobody will know. Once a hydrogen is produced, nobody will know what color it is. It is a molecule. But after but how it got produced creates a certificate value. If it is produced by green hydrogen, then it gets a certain certificate value, and that is what we are going to use to translate it from one country to the other country.
Quite interesting. So, but do you think then this will actually, the tokenizing that you're talking about, will actually transform the offtake market for green hydrogen specifically?
Yeah, so we are one of the few which is starting at the offtake agreement time itself. So when a new plant comes up and they want to get funding, they can tokenize their future produce and put it on our platform and tokenize it. So Avada will come or Adani will come and they'll say, I'm going to produce 700 tons a day for the next 10 years. So basically for 700 tons for the next 10 years, they will basically get 21,000 tokens. Now they can trade 21,000 tokens and buy, and people can buy these tokens at whatever value. And they are saying that we are going to start delivering in 28, 29, 30. So from then on, for 10 years, people can trade. So a token which is bought during this offtake time is obviously higher risk because the plant is not funded. And as the risk goes down, it's like you buying from a builder when he's just got land. You just buy a value at that point in time. And as the building gets produced more and more and gets closer to delivery, the price of the house gets higher. So we are essentially going to see investors come in early on to take commitments of the offtake early on in the process at a lower cost. And they are going to essentially give the guarantee for a long-term contract for the project to get financed, and therefore reducing the risk and their value of their investment going up. So we are basically enabling offtake. And this is what the Ministry of Renewable Energy has really liked, that we will enable offtake agreements in most countries. Others are just trading, or what you heard from H2 Global, they are looking at government subsidies and trading government subsidies. We are saying that the market has to work without government subsidies. If we only rely on government subsidies to run the market, we will not grow very fast. The government subsidies are very small. If you take a look at the electrolyzer subsidies or whatever production linked incentives of few cents that we are getting to $1, it just is not enough. So the project needs to be viable by itself. Offtake needs to be there upfront. And that's what we are enabling on the platform, offtake agreements.
Thank you so much. I'm glad you're thinking about the whole ecosystem development through this platform. Aniruddha, if I may bring you in here right now. What do you think on India's approach towards centralized and decentralized green hydrogen value chain and potential offtake?
Yeah, so I think even on this forum during this conference, I think a lot of discussions are usually centered, and I think this is something that other panelists also talked about, right? There's a lot of discussion around the large scale infrastructure, whether it is for mega multi megawatt gigawatt scale refineries, green ammonia export facilities, etc. Right? But plus a lot of good work is happening. MNRE is doing a lot of work on the policy for enabling this ecosystem, right? But like I think Sumit ji also said, right, that when we are talking about a segment that big, right, and you are trying to achieve a viability gap funding, right, for that kind of a segment, that becomes too big or too large problem to address, right, while the actual realities of costs are far from achieving unit economics, right. uh, what we are seeing is that there are a lot of pockets of applications and use cases. I think Suruchi also mentioned, right, specialty chemicals, or there are certain such use cases where they are not really looking at an alternative to 150 rupees a kg gray hydrogen, right. The moment somebody is taking a hydrogen that is transported by land, right, we are suddenly talking about competing against something like anything from even 400 rupees a kg to even as high as 1000 rupees a kg, depending on quantum of hydrogen that they're taking, right. So that is one case, right. Then a lot of applications are there where which are disconnected from the core or main energy infrastructure, energy grid, right, off grid kind of application, right. So such applications are available today. The such use cases are there today in certain pockets, right, which unfortunately get missed from the policy perspective, because it's sometimes too specific, right, where we feel that probably even the states can play a lot of role in trying to identify such localized applications and use cases and try to support those where the actual viability gap is not that much, right.
But are those scalable?
See, when we talk about scale, basically we are trying to say that how many of such use cases can be catered to, right. See, when we are talking about a smaller viability gap for each individual case, right, you automatically start seeing more projects seeing the light of the day than the feasibility studies that are actually being done, right. That's where why I was probably talking a little bit more about the projects that we are doing, is because that's the segment that we are seeing a lot of potential, right. To actually convert projects. The moment you start seeing projects getting converted, it changes the overall investor sentiment also. It encourages more people, right, to actually take the plunge, right. And then there's more demand side pull than the supply side incentives that you need to give in order to make a certain ecosystem viable. I think that's something that is some probably we as a nation can focus a little bit more, right, because there's
I'll just add
Sure,
one thing. I mean, getting demand and supply on the same platform itself is a huge step. There are enough people who want it, but they want in smaller quantities. So the demand is small, disaggregated across the country. Somebody needs to bring it together and saying, I'm going to give you offtake of 100 tons, and then I'm going to sell 1 ton to 100 people. The same problem with the shipping industry. The biggest shipping company in the world needs 500 tons a day across 500 locations. So he needs 1 ton a day in every port. It's very difficult to him to go find 1 ton a day in 500 ports. Whereas he can set up one plant himself to get 500 tons, but in a different country. So they can very easily produce 500 tons in one country and ship the green certificates to all the 500 places and be able to say, I've got 500 1-ton demands across the world. So that's the way we need to aggregate demand and make it available to the supply people to say that. I mean, we are now looking at 35 plants in Europe generating 75 tons a day demand. They want to come to India to buy. But you can't go and find those 35 people in Europe first.
Just a quick comment, and then I think in the initial stage it's fine, but in true sense of when we're talking about reducing emissions, how does that actually then, well, because still there is a certain point where you have the scale of the problem is so huge, so this whole certification works well, right? But when you're talking about really reducing the emissions locally, how do you address that?
Yeah, so hydrogen itself is reducing the emission, not the production of hydrogen. Hydrogen itself is moving fossil fuel to a lower. So we have to look at it in that context that the majority of the fossil fuel reduction or the carbon reduction is happening because somebody moved from fossil fuel to hydrogen. Now, the way you make hydrogen itself is where the discussion is, which is a much smaller amount compared to the moving fossil fuel to hydrogen, guys. So essentially, by moving people to start using hydrogen, because they can do it, you will achieve the reduction in carbon dioxide.
Quick comment, because I do want to have questions from the audience. Yeah.
Yeah. So see, another thing that happens is the moment, while you're saying that probably, this does not, come off as a very large scale in terms of number of emissions or, sort of quantum of emissions that we are, offsetting, right? But what happens is that, today we are talking about technology trying to reach in terms of certain efficiency, a certain, optimized kind of a, stage. But unless there are actually deployments of those technologies, right, that cycle does not happen, right? So if we keep thinking that, okay, let's, start working on a gigawatt scale project, right, but the viability gap is the problem to get started itself. Instead, that entire value chain starts getting rolling, right? The moment you start at a certain scale, right, you will have newer technologies coming into that. You will have people working on, for example, Suruchi mentioned, right? So technologies need to be, deployed in order for them, to
No,
continue.
I think your point is well taken, fair enough, because I know we are establishing a market ecosystem here, and I completely get it. So on that, perfectly with you on that, Aniruddha. Questions to audience. I would request that we take the comments during the lunch, and the questions will take now. And also, please introduce yourself and please limit your questions to 30 seconds.
Hello.
Yeah.
Yes, sir.
Yeah. I'm trying to understand about value chain.
Yeah. Hi, everyone. Myself, Mayank from Avada Group. So my question to Dr. Sumit Chowdhury, sir. You presented very well, and that's interesting for us to have a trade platform for the green hydrogen and all. So may I know, sir, who is going to support this and who are the promoters for all the setups?
So right now we have got funding from a couple of different providers who are global in nature. Right now, they're based in Netherlands and in the Scandinavian countries and Dubai. So we are now bringing participants to actually own the exchange in each country. So just like any other exchange, if the participants start owning the exchange, they will start using the exchange to trade. So we are going to bring in all the players in India onto the Indian platform, and they will own the exchange.
So what would be, sir, revenue models?
The revenue model is in the transaction fee that will be generated from doing this trade. Otherwise, you will go to a broker and you will pay the broker 5 to 7% to broker a deal. Instead of that, you will come to the platform and you will find your market. The market will set the thing. And so basically, you are going to pay a much smaller transaction fee on the platform to trade. It's like moving old transactions. You had brokers who used to charge a lot of money. Then you move to Zerodha, which is charging you zero. I mean, almost. But
actually, sorry, I'll have to limit the questions in all fairness to everyone. Yeah, please.
Yeah, myself, Dr. Manish Thakur, I'm involved in R&D. Especially, I would like to know about the value chain. We produce, we store and transport and utilize. So in this value chain, can you throw a light where the maximum price goes first? Because I find, in my opinion, the storing and transport is a cost-intensive process. So therefore, I want to have some idea on this issue, which one is a more economical way to produce and transport and utilize the hydrogen, green hydrogen especially.
I'll just say that for each of you, quick, like a rapid fire, just say in the way you are dealing with your customers right now, where is it happening for you? All three of you. Aniruddha, yeah, quick.
See, I think it has to be seen in two aspects. One is the capex and second is the actual opex, right? So when we talk about capex, naturally, I think the generation part today, is, a large part of the capex, right? But you talked about transportation. So when we are talking about actual, operating expenses, right? While generation, yes, again, is a large part of that. The transportation distance starts playing a big role in terms of how the costs get inflated.
Suruchi.
Sir, for me, the question is like, sorry if I'm just going to speak in Hindi. Khichdi banane ka kitna paisa lagta hai? Everything costs some money. So I don't think it's fair to say one is less than the other. There's options for everything. Of course, as a company which is a producer, we would say that storage and transportation costs more, because we would keep saying that our production costs are the lowest, but 100% it's debatable at the end of the day, because nothing compares to steam methane reformation in 2024, at least. This is the honest answer.
Rochan?
Yeah, I completely agree. So steam methane reformation. So if any of the oil refineries you see, everything is captive. And the reason is, one part of it is that the storage and transport is very expensive. If you see the if you see the smaller players, just 2 seconds. If you see the smaller players, it is costing 1,000 rupees per kg because of the addition of storage and transport.
Yeah,
We'll-
just wanted to
We'll
know,
take
sir.
2 more
Yeah,
questions. We have
only one. Yeah, I want to know if
we'll-
the utilization cost, if suppose the production, transportation, storage, transportation, how much will be the cost of utilization? Suppose you are supplying the steel industries or ammonia industry, how much will be your cost of selling at that point, end point?
I have a hard job of closing this on time.
Absolutely.
We
And
have
I
3 minutes, so I'll take
believe,
one more.
Suruchi already has answered the question. You can have a one-to-one after this.
Yeah.
So we'll go with you.
2 more. We'll take actually all 2 questions
questions
together and
last,
wrap
yes.
it up. Yeah.
My name is Dr. Kapoor. I'm advisor R&D GAIL. My question is to Dr. Sumit. So there is a producer of hydrogen, green hydrogen, and there is a user of green hydrogen. So 1 kg is produced, 1 kg is consumed. Who will get the credit? Who will get the carbon credit?
The way we are actually, we decided that we are not going to get into the concept of carbon credits at all on our platform, because there are 27 other platforms to get carbon credit. We are going to give you a hydrogen credit.
Whatever.
The hydrogen will be consumed by somebody to make green steel. The green steel will calculate how much of input cost and input carbon intensity. The user will take the, yeah. So
one last question. Yeah.
We will take one last question, please.
Yeah.
So please take the mic.
Hi, I'm Akash Goyal. I had a question for you. So what is the capex compared to like the electrolysis technologies for your technology?
It's expensive. I'm not even going to sugarcoat it at this point.
Okay, so that given simple. Okay, the gentleman there, last. That's the last question.
Yes, please. This is the last question of the session.
I'm Shukla from CSIR in Kerala. My question is to Ms. Rao. You talked about the wastewater conversion into pure hydrogen, and we are also working in that area. You talked about wastewater containing the organic contaminants. So my first question is, are you talking about the pharmaceutical or textile wastewater effluents that you are using?
Any industry, sir, has wastewater. Any wastewater would have COD. We are just
suppose
using
if you
COD.
take textiles, your capacity, what is the maximum COD level you can handle in your?
We have gone as high as 120 grams per liter. So that's 1,20,000 ppm to as low as 100 ppm. Although we will not use it to commercially produce hydrogen ever.
So maximum is 1 lakh.
Maximum can be any high. Minimum is 1,000. Anything less than 1,000 is not viable.
So
We wouldn't
there
be
is no
producing.
limit. You can
Maximum. It depends on what the organic.
My last question is that this wastewater which contains the organic contaminants, you are generating the hydrogen directly by using the wastewater, or you first you remove the organic contaminants and then generate the clean water, then use it for.
We convert the organic content to short chain fatty acids and then to electrons. Whatever is left behind is CO2 and electrons, sir. So we don't make 1:1 is not COD to hydrogen. It's Coulombic efficiency, COD to electrons.
So carbon removal and hydrogen generation are both at the same time happening.
Electron and CO2 production is simultaneous, yes, sir.
Thank you.
All right, thank you so much. And I would request our respected moderator to conclude the session.
Yeah, thank you so much. I think with the number of questions that we are hearing about, I think there's no justice to this panel, because we can continue for another half a day, I would really say. But we are at lunch hour. So let's give a big round of applause to all the presenters and panelists, Ritika, Aniruddha, Sumit, Suruchi and Rochan for a fantastic discussion. I'm sure we'll continue these deliberations. Back to you. Thank you.
Thank you so much, sir. It was absolutely indeed an amazing, insightful session on new and innovative startups in green hydrogen electrolyzer. And now we would like to honor all our eminent speakers in the dais. And I would request, of course, respected moderator, Mr. Pawan Mulukutla, the Executive Director, WRI India, to do the honor. I would request Mr. Pawan to honor Mr. Rochan Sinha, Chief Technical Officer, NewTrace, with the memento. To Ms. Suruchi Rao, Chief Executive Officer, Ossus Renewables. Dr. Sumit D. Chowdhury, Founder and Chief Executive Officer, GreenEarthX. Mr. Aniruddha Kadvekar, Founder and Director, N3E. And to Ms. Ritika Gaur, Project Marketing Head, Sohhytec. I would now like to invite on stage Mr. Vijay Bharti, Scientist D from MNRE, to honor our respected moderator, Mr. Pawan Mulukutla, with the memento. Thanking all the eminent speakers and our respected moderators and all the participants, guests, and everyone. And now I would request all our panelists as well as our respected moderator to please come forward for a photo opportunity. Indeed, an insightful session on new and innovative startups in green hydrogen electrolyzers. Thanking everyone. Have a great day and enjoy your lunch.
India, the land of a billion dreams. Dreams that would make us sustainable